Hello everyone. Welcome back to ATS SCR Automation from console app to framework. Console app help us learn and validate ideas. Framework help us scale, maintain and deliver automation in real world enterprise environments. That's why the journey from a console app to a framework is not optional, it is essential. In today's video, I'm going to walk you through a real world Selenium automation framework in C#, exactly the way it is designed and used in enterprise projects and client POCs. We will look at the solution structure, driver management, base test design, and page object model. Finally, we will run a live login test from end to end. If you are preparing for interviews, client demos, or framework design discussions, this video is definitely for you. One important thing to note about this framework is the code is completely self-explanatory. Every class, method, and critical line is written with clean code principles in mind. Instead of maintaining separate nodes or bulky documentation, the code itself explains the intent through meaningful naming and clear line comments. We strongly believe that code should explain itself, comments should clarify intent, and documentation should live inside the framework. To make learning easier, the complete GitHub repository is provided. You can download or clone the repo, explore the framework locally, run the test, and understand the execution flow end to end, from configuration to driver setup, page objects, utilities, and test execution. I highly recommend going through the framework hands on. Each file you can explore, follow the execution flow, understand how all components work together. This mirrors real-world enterprise frameworks, where clarity and maintainability are always preferred over documentation that becomes outdated over time. So once again, the full GitHub repository is available. Download it, run it, and explore it. Let the code guide your learning. First, we will check framework overview. Let me show you the overall structure of the framework. If you see, this is clean project divided into logical folders. Exactly how I design frameworks in real projects. Folder structure, if you see, we have core folder where framework foundation for DriverFactory and BaseTest is available. Pages, page object model, dashboard page, and login page. Utilities, we have reusable helpers, wait helpers. Test, NUnit, test cases, login test.cs file. Configurations handling is through app settings and framework settings. This separation makes the framework stable, maintainable, and easy to explain in interviews or client POCs. The second is the core layer. Now we will discuss more about the core layer, where driver and base test are used. DriverFactory is the heart of the framework. DriverFactory is responsible for creating and configuring the web driver. We have centralized driver creation, Chrome options handling. If you see, we have Chrome options handling, headless execution. We can say whether it should be headless or non-headless. Selenium for Selenium Manager, no driver exe is required, which means Selenium Manager will control the Chrome driver exe execution where Chrome is necessary. So we do not require Chrome driver to be downloaded separately. Like if the Chrome version is outdated or if it is to be updated, that will be taken care by the Selenium Manager. This approach avoids duplication and allows us to easily extend to Edge, Firefox, Selenium Grid, or Docker later. The same how I created for Chrome can be created for Firefox, Edge, and others. DriverFactory is where browser creation is centralized. Tests don't care whether it is Chrome or headless. They simply ask for a driver. So from this, what we get is a driver. We explicitly disable implicit waits. Implicit waits can be given here, but we are avoiding it. We only use explicit waits. This avoids unpredictable synchronization issues and make test failures deterministic. Next is the base test. This is the backbone of the framework. We have one-time setup where we load the config and create the driver. Here we load the config files, that is from the settings file. These values we will be reading through config. And we have setup, where we navigate to the base URL. The base URL is coming from the app settings file only. Again, we have one-time teardown, where it runs after all the tests are completed, where the browser will be quit and closed safely. Any memory which is there, it will also be released. Every test inherits from this class, which means we'll be inheriting all the classes from this base page itself, where it will help us in clean lifecycle management, which is mandatory in enterprise frameworks. Next is the configuration handling. Configuration handling is app settings and framework settings. These values are used in the reading the config file. So what does it contain? All the environment specific values are external, which means I can edit this file at any time, which will contain the base URL, browser, headless mode, credentials, and default wait time. This allows us to control the entire framework without touching the code. So as you can see, for demo purpose, I am using the username password here, but in real time, never commit real credentials. Use environment variables or secure pipelines. Next is the page object model. We have used page object model, where in the login page we have locators private. If you see, I have created locators private here, and also page exposes behavior, not accessions. What does it mean is actions are exposed as methods. If you see, the actions are exposed as methods. No test logic inside these pages. If you see, I have not written any logic actually. The logic will be called from the login test, but here they are only actions, which are called methods. In the dashboard page, we have verification steps, whether the application is fully loaded and does it contain any menu items. If you see, I have created a locator and a method to check whether it is fully loaded, and also verifying whether that particular home page has menu items. Instead of checking URLs or titles, we are validating a stable UI element, which is far more reliable in real applications. Next is the utilities section, which is having wait helper. Instead of writing WebDriver wait everywhere, we created a reusable wait helper. These are reusable wait helpers. Wait for usable, wait for clickable, wait for URL contains. This avoids flaky tests and keep code clean and consistent. Next layer is test layer. In the test layer, this inherits from the base test. As I previously said, all the tests will be inheriting from base test. Use page objects. We create a object for the pages we created here. Contains clean accessions. If you see, we have accessions. Has no driver or wait logic. Here we have not written any driver or wait logics. That is defined in the wait helper section. The test design has to be followed this way, so that the test doesn't know how login works. It only verifies that a valid user reaches the dashboard. If you see, a valid user, first he will open the login form, login, and then verify the dashboard. This is exactly what interiors and client expect. Next section is we will run the test, this login test, and how it is getting executed. So to execute the test, first we need to go to the test explorer, check the test case, and run it. So what it will do, first it will launch the browser, which is been coming from BaseTest and DriverFactory. Once the browser is loaded, it will launch the URL. It will click on login button. Once login is successful, it will enter username, password, and once it enters username, password, it has checked whether the dashboard is loaded. which means the left menu, it tried to validate and assertion was there. That's why we are able to run the test successfully. So the framework, whichever is there here, is a clean, scalable, and maintainable framework. This can be used for interview or client demo or easily extendable. We can extend this framework to more advanced features like extend reports or parallel execution or Azure DevOps CI/CD setup. Hope this framework help you learn more. As I said, I have explained the core basic functionalities of the framework. In detail, the code explanation is self-explanatory. I have written here so that why this is being used and why the seal keyword is used, why we are using this particular model, and also the hierarchy, how that particular test is following, and why this test is well designed. All the steps are written in the pages itself for self-explanatory.